Hi everyone, this is Lan Chen. I'm a PhD student in that love kinetics group here in NC State University. And in this video, I will show you how to build and set up an autosampler for rapid small-scale column test. Okay, so now we can start to build the main part of the autosampler. First, you need two linear stage and two 3D printing parts. This is a vial rack, and this is a connector to connect two linear stage together. And what you need to do first is to open this part for one of the linear stage. You need to open this two black part and take the screw out because we need that screw to be at this position instead of the top. We can just take this part out. We can just use a screwdriver to take it out. Take the bolts out. This one is so okay. Now you have to take both of the black shield out, and then you will take the bolts out, and then you will put them on the side of the linear stage at here. From each side, you will put one, and then you close them back. To make sure it's secure. Okay. And now you take another linear stage, the one that you didn't open the black shell, and then flip it over. Then you can use the connector to connect it to this linear stage first. So you will take the M4X12 screw first. You can take 4 of them. You need to screw them in like in this position. Make sure the bolts is in the correct position. Okay, and just screw in. And now you take the one that has been opened, the shield has been opened before back, and then put this one on the top of the other one. Make sure this part is facing the motor of the linear stage. So you put it like this. Okay, now you can, using the M6x16 screw to secure them. So you first make sure the bolts is in the right position. Okay. now you can use a hex screwdriver to make sure it's secure. And now it's not very stable because this part is very heavy. So now we need to use two plastic board to make sure it's stable. Now we can just turn this whole thing around. And using these two boards to connect it at each part of the two sides of the linear stage, and then we can make sure it's stable. So this is just two PVC board with a screw hole on it. So you can, I asked my lab manager to help me build this, to help me make this, but maybe you can find some place to build something similar. So now we need to connect two stands to the two sides of the linear stage to make sure it's stable, and then we will need to use still the M4 screw, but the length of the screw is depending on how thick your board is. So now we can just connect it. So now what you need to do is to connect this vial rack on the top of the top linear stage. So still make sure that this part is facing on the motor of the linear stage. And then there is a screw hole there. Release a left for the screw, for the hex screw. Use the two screw that is close to the motor. And then you just make sure they are in the right position. Okay. This is the M6 times 16. Put them in. Okay, so we have the Arduino Uno board and the CNC shield. So first we need to connect these two together. So it's very easy to connect. You just plug them in. Okay. And then we need to add jumper to the CNC shield. So jumper will make the linear stage work more smoothly. The CNC board to make sure it moves smoothly, so we need to add it into this position. This is the first jumper where it should go, and then the second jumper go here. And then we want to connect the motor driver to the CNC board. So first, with the motor driver, they also provided this part is for preventing the driver to be overheated. So you just peel this part and then stick them on. Okay, and then you can connect them to here. We need two because we have two linear stages. What we need to do next is that we need to adjust the current limit for the driver. So you see here you can adjust this to adjust the current limit. So the two linear stages that we're using have a limit current of 1.7 amp, and we need to adjust this to be half of that number. So what we need to do that, we need a multimeter and a power supply and also a laptop and an alligator clip. So first, we open our laptop. We don't need to do anything to the laptop connector to connect the board to the computer. So first we connect it to the computer. Okay. You can see the lights of the Arduino board is powered, and then we will need to connect the other. We also need to give it an extra power supply to connect this to the CNC shield. So to connect this to the CNC shield, we will need these things. So we need to wire to connect this with the CNC shield. We need to use this wire to connect the power to the CNC shield. So first we just take two of them out and choose the black one and the white one. And then we'll use a screwdriver. And just put them in to each one of the port and then fasten it. And then on the other side we will connect it to the CNC shield. So as you can see, this part is a negative part and this is a positive. So we need to connect the negative sign to the negative sign and positive sign to the positive sign. So the white wire should go to the negative. You can disconnect this first. Now we can power the board and the CNC shield. First we connected this to the computer. And then we connect this part to the external power supply here. So now we can start to use a multimeter to adjust the current limit to this thing. So now what we need to do is to adjust this very small pin to adjust the voltage that flows through the motor. So there is a current limit of the linear stage motor, and if it's above that current limit, it will burn the linear stage. So we need to adjust the voltage to be half of the current limit. And the linear stage we're using right now has a current limit of 1.7. So we need to adjust that to, I personally like to adjust it to be a little bit smaller than half of that value. So I would like to adjust it to 7.5. Using an alligator clip to connect it to this side and also connect it to your screwdriver, and then use the other part, put it on the negative side, negative charge part, and then put it out here. And then in the multimeter you can see the current voltage is 1.448. So you will want to adjust that to 0.75. So we can twist it clockwise, and you can see the voltage is decreasing. You can see 7.75. And then at this part we do the same. We twist it clockwise. Now we can disconnect the power, external power, and disconnect it from your computer. Okay, and this part is done. The switch, so this is two tiny switch that will help the linear stage to know where is the zero position. So we need to use these wires. You can just choose two colors that you like. Use the white and black. Remember to make it a little bit longer, because when your linear stage moves, you will need it to be longer enough so the linear stage can move. Okay. So this will be enough, I think. And then you cut it. Okay, and then we can use black. They need to be in the same length. Okay. And then for both sides of the wire, you need to cut the outside plastic rubber and make the inside wire exposed. So you can use the small hole here to do that. So it's like this. You need to do that to all your wires. Okay. But also don't cut it too long. This white part is just too long. We can just cut it a little bit. And this one. Don't need to cut it too long. So these two wires, one side need to be slightly longer, and the other side need to be slightly shorter. Compare them. First, we need to work with the side with longer wire, and we need to connect them to the switch. So we can use like for example there is a 3 pin that you can connect it with. This one is the ground one, and these two are the switch. So we need to use this pin and this pin, the center one and the one close to this part. So we just go in and then wire it. Okay, for the black one, same thing. To go in. So we can use in soldering station to just make it more secure and not that easily to be disconnected. And on the other side, we need to connect it to a pin like this. So, and then we will use this pin to connect the switch to the Arduino board. Yeah. So first we need to cut this pin. So we only need 2, so we can use this to cut it. Not bad. So now we have this pin, and now we can just using a rack to connect it. Okay. this part we need to reinforce it and make sure it is secure and will not be disconnected. So we just add some soldering to it. Yeah. We'll need to do that for the other switch too. So now we will have two switch. On this side is a two switch, and on the other side is the pin connector. We can connect it to the Arduino and CNC board. And because this will be like a tangled in the future, so we can use the cable ties to tie it up. Can start to build skirt to mount the real-time clock. So this is a real-time clock, and it will need to be powered by the CR1220 coin battery. So first we need to attach this to the real-time clock. So I need to cut it. 4 is enough. Let's do 4. So there's a 4 pin here. So we just connected it using the soldering to connect it. So we need to start it with ground. You can see there's a very small words here. There's ground, 5V, ADS, and SCL. We don't need the SQW, SQM, or we don't need that port. So we are not going to use that port. So 4 pin is enough. So now you're done with the soldering. The next thing you need to do is connect it with the wire. So we have 4 pin here. We only need 4 wires here. So you need to use the vial that both sides is looking like this. So we need 4 of the vial, and now we just plug it in. Insert the coin battery like this in this direction. Okay, and then you can start to, and then this is finished. Now let's start to put the switch and the Arduino real-time clock into our main board. So here we start with the real-time clock. So what we do is that, if you can see, there's a small words here, and in the CNC shield there is also area for the real-time clock, and it also have small words here. So we need to connect each of the port to the related port. This is how it should look when you mounted all the pin into the CNC shield. So here you can see there's a small words here called GND, 5V, and here is SDA and SCL. So on the CNC board, there's also area has all those words here. So you need to connect the GND to the GND, and the 5V to the 5V. So for example, here we are using a black wire to connect the GND to the GND here. And also the 5V is a white wire. We connect it with the 5V here, if you can see. And then same for the gray line and the purple line. And this is how it should look at the end. Now we can start to wire the switch. So you can see that there's 2 lines. One is connected on the center, the other is connected on the ground. So we need to, where we should put this switch, we should put it at here. So you can see on this area there is an end-stops area. So we need to put, where we should put this switch, we should put it at here. So you can see on this area there is an end stops area. So we need to put, where we should put this switch, we should put it at here. So you can see on this area there is an end stops area. So we need to put, where we should put this switch, we should put it at here. So you can see on this area there is an end stops area. So we need to put each one of them on the X plus and Y plus. So you need to make sure that the center line is connected to the outside of this X plus or Y plus. For example, for this one, the center line is the black line and the ground line is the white line. So on the other side, right here, the black is the center one, the white is a grounded pin, grounded port. So we want to connect it to the X plus. So we will just plug it in simply like this. The other switch is the same. You now see that the blue line is from the center pin. So on this side, we use the blue to connect it from the outside of the pin. So from the X, Y plus, if you can see that. Okay, this is how it should look at the end. Okay, so now we are at the last step of building the auto samplers. So we need to connect our main part to the board. So when you purchase the linear stage, they will come up with some kind of wire like this. So it's very user-friendly. You just need to open it and connect it to the linear stage. Plug it in, and on the other side, plug it into this two port. You can, so I normally select the this one as X and this one as Y. So when you connect the top linear stage, you need to connect it to the X area. So you can see there is an X here. So make sure you put the red line on the outside, on this direction. And then you just plug it in. And now you can using the same method to connect the other linear stage to your board. Still plug it in. And then this port, connect it to the Y area. Can you see that Y? Maybe like this. Can you see that Y? There is a Y. Okay. Okay. Now it's connected. You connect the switch to the auto sampler tube. So you also need to check which one is X, which one is Y. The white and the black one is X, and the yellow and blue switch is Y. So this one should go on the top. So you need to put the black and white switch on the top of the linear on the top linear stage, and we can normally just put it in, but sometimes it's not secure and it may come out. So we can use a hot glue gun or the other kind of glue to attach it to that position. You can use whatever is convenient for you. Don't need to be too much. So it's nice and secure to be there. And the other switch, the blue and the yellow switch, as we just said, it should go to the Y linear stage, so it should go here. So we need to put it here at this connector. And glue on the top. Okay. Now we insert it in. In this part of the video, I will talk about the workflow of setting up an Arduino code, and I will also explain the Arduino code just descriptively. This means that I will not upload the code right now, but in the next part of the video, I will go to the lab and walk you through all the steps of setting up Arduino code and setting up the autosamplers. So before we start, I want to show you the folder that I will share along with this video to you. So in this folder, we have a few very important documents. I have put the 3D printing file into the folder that you can use to print the 3D printing parts. And I have also put the necessary Arduino code into the folder. And also a spreadsheet about a PowerPoint sheet about the autosampler workflow, and also a purchase list for build and autosamplers. So I have put some Amazon link into the purchase list, but they are not the only choice you have. You can definitely buy exactly same stuff from a different store or different place. Okay, so let's start to talk about the workflow of setting up the Arduino code. The first thing we need to do is set a real-time clock. So in this step, we will tell the board what time it is right now, and the board will execute the remaining code based on the time we tell the board. So after that, we can run a read test to make sure that the time we set it in the board is correct, and then we can set a dripping position. So I will talk a little bit more later about what is dripping position and how to set it. And then we will test our autosampler, and then we can apply the real-time dimensions to the Arduino code. So if this is your first time using Arduino, please remember to install the library listed at here. So to do that, you need to first open your Arduino and then go to Tools, Manage Libraries. Okay, and in this box, you will search the name of the Arduino library. For example, the first one, Excel Stepper. Now here it is. So you can click install, and then it will be installed. And then we go to the next library, DS1307 RTC. So here it is. We can click install. And also when you search DS1307 RTC, the time library will also show up here. And you will need to click install. And after you have installed those three libraries, you can click OK. So to make you understand the Arduino code quickly and clearly, I'm giving you an example problem here, like an example RSCT. So let's say you need to run RSCT, and the RSCT will start at 3 p.m. and you need to connect both TLC samples and PFAS samples for every 1.5 hours. That means your sample gap is 1.5 hours. And the first sample, and also means the first sample need to be connected at 4:30 p.m. So the flow rate of the RSCT is 5 mil per minute, and you need to connect 40 mil of samples for TLC. That means your sample duration for TLC is 8 minutes. So 40 divided by 5 is equal to 8 minutes. And you need to connect 20 mil samples for PFAS. That means the sample duration for PFAS is 4 minutes. That's 20 divided by 5, which is 4. And one thing to be noticed is that the sample duration for TOC and sample duration for PFAS is included in the sample gap for the autosampler. So the real sample gap need to be subtract 8 minutes and 4 minutes. That means the real time sample gap is actually 17.8 minutes. Okay, so here is a top view of our autosamplers. We have two linear stage. We call this one Y linear stage, and we call this one X linear stage. So as we just talked, we need to set the dripping position for the autosamplers. But before we set in the dripping position, we need to know where is the zero position of the autosampler. So zero position is a position where the vial holder will stop when the autosampler is not connecting samples. So, and the dripping position is the effluent dripping point of your rapid small scale column test. So how autosampler works is basically the two linear stage will move the vial holder back and forth between the zero position and dripping position to connecting samples. And you will put your sample vials into the vial holder, and then it will help you to connect samples. Of course, with the cap open. So as we talked in the example, we need to connect two kind of samples, TOC samples and the PFAS samples. So I will put TOC samples on the top row and PFAS samples, sample vial on the bottom row. So this column of the sample will be the first batch of sample, and this will be the second set of sample. This will be the third set of sample, fourth set of sample, and fifth set of sample. Let's talk more about zero position. So if you remember when we build the autosampler, we have two switches at this side and at this side. So these two switches is designed to help you to define the zero position. So when you finish to build your autosampler, your vial holder is probably not at the zero position, but the code will help you to find the zero position. So for example, when you finish to build your autosampler, your vial holder may at this position. So when you start to after you upload your Arduino code, the two linear stage will move your vial holder towards the X direction first, towards the motor part. And when the switch has been clicked by the motor shield, it will stop. And then it will start to move towards the Y direction, towards the motor part. And then until the switch being clicked. And until it's been clicked, the code will make the vial holder move back a little bit, just a little bit, to release the switch, and also from Y direction to release the switch. And then it will stop there and define that position as zero position. And it waits there until it's the time for the autosampler to go out for sampling. And when it is at the time for the autosampler to go out for sampling, there is a lot of different paths that you can make the autosampler move to do the sampling. But in this video, I will show you the most simple one. There may be some drawback about the about this path, but it's the most simple one, and I will use this as an example. So later, if you understand this path, you can just design your own path to connecting samples, to connect samples. So for the path that I will show you in this video, the two linear stage will move your vial holder towards the y direction first until this position. And then the x linear stage will move your vial holder upward. Not exactly upward, but through the positive x direction until it reaches this position. It will stop there and wait for the sample duration time for TOC. After it finishes connecting sample for TOC, it will move forward to this position to connecting sample for PFAS. And after it finishes connecting sample for PFAS, it will run back to 0 position. Just directly run back from X direction first. When it reaches the 0 position, it will run towards Y direction then, and until it reaches the 0 position. So there is a drawback of this path, which is when it runs back to 0 position towards the X direction, some of the water may drip into the TOC vial where you already have samples in it. So in my experiment, I use this path because it's simple and there is like very small area for arrow. Even though there is a few drops of water will dripping into the TOC vial, it doesn't matter. It wouldn't change the TOC value. The PFAS samples will be the most important one, so I want to put it on the bottom to make sure there's no the other water dripping into it or contaminated the samples. So after it go back to 0 position, and it will wait for the sample gap. In the example, it will wait for about 1.5 hours, and then it will go out to connecting second sample. So it will still move towards the Y direction first, but it will move a little bit more until it stops at this position, and then it will go to X direction, and then sampling for PFAS, and then go back to 0 position, and then go back. And it's the same for position 3, position 4, and position 5. Yeah, so as some of you may find that the dripping position is very important. So basically, we need to we need to calibrate the autosampler to make the dripping position drip into the sample vials exactly at the center of the sample vial. Otherwise, the water may be dripping out of the vial and you will miss that samples. So now I will show you how you can use a code to define the dripping position. And this code is also same as it's also very similar to the main code that we will use to run the autosampler too. So please pay attention. Oh, before that, well, let's just go as the workflow. So the first step is for setting up Arduino is to set a real-time clock. So to do that, so the code for set up real-time clock is already built in the DS1307 RTC code. So we can go to the Arduino file, click File, and click Examples, and find the DS1307 RTC. So this option will only show up after you install the library. If you didn't install the library successfully, you will not find this at here. So find it and go to Set Time. So This is an example code, but we basically are using this code to set the real-time clock, and you don't need to change anything except here in this code. So when you are opening that example code, if in this code it was write as time.h instead of time lib.h, you need to manually change it to time lib.h. Exactly the same. Remember the L is a uppercase. So if you don't change that, there will be a trouble and you will not be able to run that code. So there is a 3 button here on the top. This is for verifying if there is any error on your code. This is for upload, and this is a serial monitor for you to see if your code has been run correctly. So so we are not going to upload the code in this section, but on the next section of the video, I will upload the code. So, but we are able to verify the code. So we can verify. It says done compiling. That means there is no error in the code. So, okay. Now, next step. So, and then we can start to upload the code into the board. Yeah, but I'm not going to show you right now. I will show you in the next section of the video. So this is for set the time, and the next step is run a read test for the real-time clock. So we can close this one first. And the read test code is also the same example code is a example code in the same place. So we click File and Examples, DS1307RTC. We choose read test. Okay. So same, if in your code here is written as TIME instead of TIME LIB, please add a LIB here. And then you can verify your code and upload your code. And then you can open your serial monitor in the real case. I will show you in the next video to see if the code has been uploaded correctly. And then you close it. That's for the second step. Now we can set for the dripping position. So on the file, we click open and find the folder that I shared with you. Here in the Arduino code folder, you open the autosampler 200 by 200 dripping position. So I put the 200 by 200 here is because the length of the linear stage we are using in this autosampler is 200 centimeters. So we open that file. Okay, so at the top here is just include the library. You don't need to change that, except this one. I think it should be correct, but if it's written as time instead of time lib, please change it to time lib. Okay, and this part you don't need to change it too. So most of the part in the dripping position code you don't need to change. There is only one part, and there is like only few part. I will talk later. So this is just setting the pin from the board. Please don't change them. And here is set the sample duration for TLC and sample duration for PFAS, and also sample gap. So in the example we just show we have a sample duration for TLC as 8 minutes and sample duration for PFAS as 4 minutes. But here we are only trying to define the dripping position. So we will want to keep this time very short, so it won't affect the final result. So in the final code, we may need to change it to the real time dimensions. So maybe I can show you how the setting dripping position works. So in this code, it will first homing your autosampler to make the while holder go back to the 0 position, and then it will move your while holder towards the y direction and then towards the x direction. So when you were giving it a number to let it give it a distance to let it move, it may move at this direction and it will stop. And we will let the while holder to stop here for a very long time, longer enough for you to calibrate the position of your autosampler. So once your while holder is stopped at here, you can just manually move the whole autosampler to make them effluent of the rapid small scale column test dripped into the first TLC vial. Okay, so that's what you need to do. And then at the end of the setting dripping position section, your vial would be your autosampler will be look like this. So let's go back to the code. Because we are not really netted autosampler running, so it doesn't matter about what value we are giving at here. And this code is for setting the start time for the autosampler to go out to sampling the first samples, because we are just setting the dripping position at this time, so it also doesn't matter what value you put it here. And here in this section, it is defined the maximum speed of the linear stage, so how fast the linear stage move. Please do not change this number. If you change them to a too large number, it may burn your board. And this is define the home speed, like the speed the linear stage will move the vial back to 0 position. So also please don't change that. And this whole part is for homing. For homing, homing means moving the vial holder back to means define the 0 position and moving the vial holder back to 0 position. So one part you need to be noticed is this part. So as I have just mentioned, how the linear stage how the autosampler find its 0 position is that it will move toward this direction until the switch being clicked, and then it will move back a little bit and to release the switch and define that position as 0 position. So in this case, sometimes you will meet a problem is that your dripping position and your 0 position is too far away from each other. It's not really a problem. It will only cause an issue that the travel time become too long and it may waste some time. So it may waste some time during the trip. So a way to solve this problem is to make it move a little bit more after it, move it back a little bit more after the switch being clicked. So instead of just move back a little bit to release the switch, it will move back much more to a position that is closer to the dripping position to save you some travel time in the future sampling section. Okay, so this code is doing that. So if you and also one thing I need to say that in this code, someplace you can see there is a 2/ things. So if you put a 2/ in any of the code, it will comment that line. So it will make that code as a comment. So when you are verifying or upload that code, it will skip that line. So in this part, if you want to make your vial holder closer to your dripping position, instead of just move back a little bit, you can use this for code I'm highlighting right now. If you don't want to do that, if you just want it to move back a little bit and set that position as 0 position, you can comment this for code, and uncomment this code. So because in this example, I want it to be closer to the dripping position, I would prefer to comment this code and uncomment these 4 codes. And also, so the number in this parenthesis is like a distance you want the vial holder move. So even though this is a very large number, it will actually only let the vial holder move for a very small distance. So here I will actually let the vial holder move for very longer distance. And the reason why I put the same code twice here is because I want the vial holder move x direction for 12 steps. So one step for one step the vial holder will move negative 4,200 small micro steps. So I want it to move back 12 steps. But so there is a bug in this autosampler, is that if the large step, if this 6 number is over 7, I think it's over 7 or over a certain amount of steps, it will moving on the opposite direction as you want. So like you want it to move upward, but if you put a 7 or 8 or 12, it will move downward instead. So an easy way to solve this is just you separate them into a 2 code. You just let it move upward for 6 steps and then move it upward for another 6 steps. Okay. So this code is still for setting up the time to let the linear stage know the time and run as the time we wanted. And here this code is also very important. This code is working together with the time we have set it up on the top. It will working together with the time we set up at here. However, because we're now only trying to calibrate for the dripping position, it doesn't matter. We don't want the autosampler stop and wait for a certain time and start and then begin to run. We want the autosampler to run immediately after we upload the code. So in this code, I will just comment this whole code, put 2 slash in front of them. So, and now we reach the most important part, the main part of the code. And before we are talking, this is a void loop. So before we are talking about this void loop, I want to talk about the remaining part. So remaining part is, I want to explain them, but I also want you to know to please do not change them and do not change anything into this part. So in this part, it has defined 5 very important functions that you will use in the void loop. So you will use these 5 function in this void loop. So the first function is run x to cm. This means run x 2 centimeter. So this code will move the vial holder towards the x direction, towards this direction. So run y 2 centimeter will bring the vial holder towards this direction, towards y direction. And run x back will bring the vial holder back to 0 position. Run y back will bring the vial holder back to 0 position among the y linear stage. And the final code is wait seconds. Wait seconds is just let the vial holder to stop at that position for a certain amount of time. So now we can go back to the void loop section. So in this void loop, I have only put 3 comments here. So first is run y to centimeter 6. In this code, so let's first start from the 0 position. Let's say this is the 0 position we defined. It will first run y to centimeter 6. And it will run towards this direction at this position. And then it will run x to centimeter 6. So it will run towards that direction. And then it will wait for a long time. So the time you put here is the unit of time is seconds. And I'm putting here 24 hours. I let it wait for 24 hours so I have enough time to adjust the whole position of my autosampler. So let's say it stopped. Let's say after it run these 2 code and stop for 24, stop there for 24 hours, it stops at this position. And you see the effluent water will be dripping out of the correct position. And then we can manually move the whole autosampler to the correct position. Okay. And we will just keep the autosampler in that position the whole time. And that's what we need to do for calibrating the dripping position. Now we can go to the next step, which is test the autosampler. What we do in the test autosampler is that we need to make sure that when the autosampler is moving and stopping, effluent water is dripping into the center of the vial holder, so the water will not being waste or being dripping into a wrong direction and not being connected. So to do that, we have the other code. Let's close this one first and save it and the file. Go back to the folder. In Arduino code, you need to choose the test 1. I will explain later about what is test 2, but now we choose test 1. Can open it. So this test code, most of the part is almost exactly the same. It's exactly the same as the setting dripping position code. It also has the library part, the pin part, the sample duration part, and we want to keep it as 5, 5, 10 at here because we are only testing. We don't want to waste too many time to let it sit there for too long. And it's all the same. And for this part, this is for setting the 0 position. Just remember whatever number you are using in setting up the dripping position, you need to have exactly the same number here in the test code. For example, if you in the setting dripping position code, you set this number as 4. In this test code, you also need to set this number as 4. Just keep them the same. And this is all the same. So in the void loop, This is a main difference between the test and the setting dripping position code. So in this code, let me explain the void loop. So everything in the void loop will be run over and over and over again. So and within the void loop, we have a for loop. So for loop will first set the I equal to 0, and after it finishes first run, it will go back to the for loop, and now I will be set equal to 1, and then it will run again, and then go back to the for loop, and until I is equal to 4, it will still run it, and then it go back, I will be equal to 5, and it will break out the for loop, and it will jump out from the for loop and back to the void loop, and the void loop will make it run back to the for loop, and then I will be set to 0 again. So within the loop, so if you upload this code, the code will make the file holder move the file holder back to the 0 position, and then this code will run file holder to 3 steps towards the y direction at this position, and you will run it towards the x direction for 6 steps, and then wait for sample duration time for TLC, which has been set as 5 seconds. And then it will run x to 5 steps towards the x direction, and it will stop there and run sample duration for pfas. It will also stop there for 5 seconds, and then it will run x back to 0. So it will run towards the x linear stage to the 0 position, and run y back to 0. So it will run towards the y linear stage to the 0 position, and stop there and wait for sample gap, which has been set as 10 seconds. And then it will go to the next for loop when I equal to 1, and then it will go to the second position and do the whole stuff again. So the reason we want to run a test is because the number here may not be accurate. You may want to calibrate a little bit, like maybe change the 6 to 5 or to 7 based on your real case, or maybe change the 3 to 4, or change the 5 to 6. So this number you need to change based on your real condition, or you can also change the path of the movement, just basically using this for code flexibly and make your own path. It's all okay. So another things need to be remembered is that when you are running a test, you may also want to record the time that the vial holder moved from 0 position to the dripping position. So because we want to make our autosampler as accurate as it can. So if we have recorded that time, we can subtract that time from the sample gap. For example, the sample gap of the between two batch of sample is 1.5 hours, and the sample time required from the vial holder move from 0 position to the dripping position is 15 seconds. Then you need to subtract that time from the sample gap. And because like moving from the first position to the dripping position for the first TLC position is shorter than moving from the 0 position to the dripping position for the last sample. so the time is different. But what I did was, what I will do is that I will count the time requirement for each of the steps, and I will average them and subtract them from the sample gap. I think that's the best you can do to increase the accuracy of the sampling time. Okay, after you have changed all these numbers, so and another thing need to be noticed is that run X back and run Y back, these two codes can only be set as 0. You can put the other numbers at here, but I recommend you to only put 0 at here. So only let it run back to 0 position, and only change these numbers 1, 2, 3, 4. Change these 4 numbers to make the water dripping out from the dripping position into the correct. Make sure it's dripping into the correct position for each of the vial. Once you have calibrated your autosampler and know that it will do the job, you can start to apply the real-time dimension to the Arduino code. So to do that, you can just you can just first save the test file. And then go back to the top. So now we can apply the real-time dimension to the Arduino code, which means we are working on the final Arduino code. So we can just work on that based on the test code we just calibrated. So we need to go on the top to change the sample duration TOC to the correct value. So let's go to the example. So from the example, we can see that the sample duration for TOC is 8 minutes, and we can just change this number to 8 times 16. That's 8 minutes. So the sample duration here, the time you give here, it has a unit of seconds. And sample duration for PFAS is 4 minutes. 4 times 16. And the sample gap here, we have calculated to be 78 minutes. So we just change it to 78 times 16. Okay, and the start hour. Start hour is the first sample that for the sampling time for the first samples. So the first sample will be connected at 4:30, and we will put 16 as a start hour and 29 as start minutes and 46 as the start second. The reason we put 46, the reason we subtract 40 seconds is because the time for the autosampler move from the 0 position to dripping position will take 40 seconds, so we have subtracted that value. And remember, when you enter the time here, you need to enter the 24-hour time instead of 12-hour time. So we put 16 here instead of 4 as the start hour. And this part you don't need to change, and just keep them the same as you calibrated. And remember to delete the 2/ at the wait for times. Otherwise, the autosampler will move immediately after you upload the upload the code. And when you delete that, it's done. So this is your final code for running the autosamplers, and you can save it as another file. Save as final. Okay, save. and this is saved. So that basically is how you will setting up your Arduino code. And the last part I need to talk about is so in the Arduino code, I have also provided another code, which is PFAS test 2. So the only difference between this code and the test 1 is that I set some of the number to negative instead of positive, and also I changed some number from the negative to positive. The reason that I provide this code to you is because when I was designing the autosampler, I find that some of the linear stage when they were building the linear stage, I guess they made some mistake with the line. So because there's a 4 line connected from the linear stage to your Arduino board. If the line was not in the correct sequence, when you were uploading your code, it will move to the opposite direction as you want. So the easiest way to solve that is just you ask it to move to the opposite direction and it will move to the correct direction. So that's why I provided a second Arduino code with some of the parameters set to be a negative value as was set into the first test code. So just when you were testing your autosamplers, if you find that the Arduino, the linear stage was moving on the opposite direction as you imagined, then you just switch it to the second test code, and it will solve the problem. Okay. Here is the same. It's like a different. It's like a negative value of the first code. So this is the end of this part of the video. In next part, I will go to the lab and show you how to set up the Arduino code and the autosamplers. So hi, so in this part I will walk you through the whole process of how to set up your autosampler and how to set up your rapid small scale column test. So here we have a rapid small scale column test here. It's an upflow column. That means the water is going from here, and the effluent will go out from here. And there is a funnel there to connect your waste, and your waste will go down to the waste carboy. And this carboy is the influent carboy. So the influent carboy will take water. The pump will take water from the influent carboy out and go through the rapid small scale column test, and then down to the waste carboy. So now, as you can see, we already have autosampler put at here, and it will be held by a milk crate. And now we can start to set up the Arduino code. So as you remember, in the spreadsheet, in the PowerPoint slides, I have shown you the basic workflow of setting up the autosamplers. So the first step we need to do is to set the real-time clock. And here we have the board at here, and on the back side of here we have two external charge. But first we can connect the board with your computer. Okay. And now we already have our Arduino open, and now we can open the real-time clock code. So we go to File, Examples, and DS1307 RTC, we go to set time, and here is the code. Before we upload the code, we need to make sure we are using the right board, Arduino Uno, and right port. And here, this is the one we should choose. Okay, so now we can verify the code. And then we can upload the code. We can open the monitor serial, and after it's updated, it will show you it has been read. So the autosampler is reading the time now as April 7th at 2 p.m. 2:31 p.m. Okay, so we can close it. Now we can go to the next step. Next steps is to verify the time has been uploaded correctly. Now we can, which is running a read time test. So we still go to File, Examples, and DS1307 RTC. We'll open the read test code. And same step, we'll first verify the code. Instead done compiling, so that means this has been verified, and then we upload it. And we'll open the serial monitor. Okay, so you can see that the board is now reading the time right now, second by second. Okay, so we can close it. The next step is to setting up the dripping position of the autosampler. So now we can start setting up our dripping position. And first we need to open the file code. So we go to File, Open, and this is the dripping position code. So we go to the folder, and now we open it. Okay, we will verify it. Okay, then we can upload. So after we upload it, we need to connect the board with from this part with your external charger. We will open the serial monitor, and then autosampler is start homing now. So it will first homing the top linear stage, and after it's clicked, it will stop there. It stopped at your first dripping position, and what you need to do is to adjust your autosampler to make the effluent water dripping into the first dripping position, which is this vial. So we will just move the whole thing a little bit towards that position. Okay. So now it's dripping into the center of your first vial. Now we are done with setting up the dripping position. We can now test our autosamplers. So we first close this serial monitor. We will close this one too. We need to open the test file. So we open test 1. As we have talked in last part of the video, we will set the sample duration to 5 seconds, and for both TLC and PFAS, and the sample gap is 10 seconds. Okay, we can verify our code and then upload. homing again. And open the serial monitor. So when you open the serial monitor, it will start running the code again. It will stop like for less than 1 second. That's okay, it doesn't matter. After you have test your autosampler, you can now change the dimension of your test code to a real dimension. Like here now for sample duration for TLC, you can change it to 8 minutes. And here sample duration for PFAS, like 4 minutes. And then sample gap is 78 minutes. And then you will need to change your start hour to a real start hour. And then you will need to delete the 2 slash from here. And then you will save this file again, give it another name, and start to run your autosampler. You can start to disconnect your autosampler from your computer, but you want to disconnect your autosampler from your computer and still make the autosampler doing what it needs to do. So to do that, we need to using the other external charger for your autosampler. Which is this part. So first, we need to connect it to your board. So there is a charger outlet right here. So you can just plug it in. And then you can disconnect it from your computer. And after you disconnect, the autosampler will still moving as it needs. One more note is that when you're done with your autosampler, you need to disconnect. Please remember to disconnect both power outlet, both external power from your board. Otherwise, it may